We are back once again. It is daily LeetCode 100 and the day is 100 and question mark. I'm not exactly sure what day it is because we switched setups and the day counter is gone, but it is a large number of days. Hopefully it'll be a multiple in the future. I'm going to do a bit of a shorter session today. It's only 45 minutes. But that being said, we have some comments to work through. So we have a comment from Nathan Ackerman. Sounds like Ackerman if you watch Attack on Titans. Good man. Keep the grind going. Love the live videos. Feel strong, man. Love your comments. Feel strong, man. Yeah, it's always cool to see that. I mean, I hope there is some value here because I'm not really certain what the value is, but we have a comment from Rockman64. I really like programming as I find it interesting, but I cannot find uses for any language I try. I actually feel this. I ran into a similar issue. So that's actually a tough thing to solve. I've learned my fair share of Java, JS, H++, HTML, and CSS, and C++, but how do I apply these? Suppose I want to create desktop applications if that helps. I feel like the way to go is to find something you want to make, and hopefully the tool or the thing you want to use can be a vehicle for that. So like if you wanted to make, for example, there's already tons of to-do applications, but if you want to make a to-do application for Windows, then you could learn Java and all the associated tools in the hopes of making that application. That way you'll pick up some actionable skills and also learn the thing you're hoping to learn. But I feel like the best way is project-based. So hopefully there could be something you could make to hopefully maybe an application you want to make for yourself or a family member, and maybe you could use that as a vehicle to kind of pretty much find a use for it. And I think that's a tough thing because I often end up in the thing where I'll often end up in the trap where I'll work on learning a language or a set of tools, but I have nothing to make, and so that learning ends up feeling kind of empty because I don't really have an end goal. So hopefully there's a balance between the two, but I'm still figuring it out myself, so I'd be interested to hear what you come up with as well, Rockman64. Also, all the Mega Man games are fire. Specifically, Mega Man X6, X7, and X4 are absolutely fire games, so you're going to want to go out and buy those as soon as possible. But we're actually a little bit strapped for time today, so I'm just going to jump straight into it. And we were stuck on a problem yesterday called count odd numbers. And yeah, I'm not exactly certain how we go from here. I think this is one of those problems. There's not a lot of coding to do, a lot more thinking to do. But yesterday my brain was fried, so I couldn't really think. Today my brain is not fried, but I'm not exactly in the mindset I usually am in, so I don't suspect we'll come up with anything clever. But we shall see. I also need to, wait a second. Oh, okay, it is set up. Okay. So we'll just pause all of this for now and think about the question. Basically, it's an easy question. We just have to count the odd numbers in an interval range. Given two non-negative integers, low and high, return the count of odd numbers between low and high. What I don't understand is if you have a range, let's say from 0 to 100, the number of odd numbers there would be 49, I believe. So maybe the odd numbers could be given by 100 divided by 2 minus 1. But what if our range was 1 to 100, then it decreases quite a bit actually. So I feel like we have to use that left-hand side somehow. Maybe we just subtract the left-hand side from it. But all this kind of falls apart when you choose something like 3 going to 7. And my environment keeps freezing and turning into just bubble gum. But Maybe it's because we're recording on Mac, but I'm not exactly certain. But we're going from 3 to 7, inclusive of both the end and the beginning. 7, there's only 4. 3 is odd, 5 is odd, and 7 is odd. If we do 7, what if you do 7 minus 3, kind of like how we calculate mid-range. Do 7 minus 3 over 2. 7 minus 3 give you 4 over 2 would give you 4 over 2, which would give you 2. The answer is actually 3. So what if you could just do high minus low over 2 plus 1? If we did 100 divided by, 100 minus, all right, let's try it for another simple case, like 8 goes to 10. We did 10 minus 8 gives you 2. 10 minus 8 gives you 2 over 2 is 1. And then we get the actual answer is 1. It feels like if our start maybe if our end range is odd, we subtract 1 instead of add 1. So we'd subtract 1. So let's take something different. I think we had a test case, which was test case 3, where the output for the range of 1 to 100, the output is supposed to be 50. So what if we did 100 minus 1, which would be 99 over 2. 99 over 2 is 49.5. Let's just say we floor it with 49. The answer is supposed to be 48. And what we said was if the end range was odd, we would subtract 1. If the end range was even, we would subtract 1. So you would, wait, it was expecting 50. What if you make this 0? If you make this 0, you still get expected answer of 50. There's a range here. There's a magical range here. 100 and 0, you get 50. We're doing high minus low right now over 2. Since we're doing high minus low over 2, what does that even mean? We're doing high minus low over 2. High minus low over 2. I don't think subtraction is the way. Maybe there's no equation based way. Or maybe we just need to take a close look at the equation. If we're going from 3 to 7 inclusive, the answer is 3. The numbers that exist here are 3, 4, 5, 6, and 7. So you get a range of 1, 2, 3, 4, 5 numbers. Of those 5 numbers, 3 of them are odd, which is the correct answer. Three of them are odd. Let's do 7. It's definitely a part of, high minus low is definitely a part of the solution, because that gives you the range of characters. High minus low, 7 minus 3 gives you 4. And of 4 numbers, we know at least 2 of them would be odd. Or we know at least half will be odd. Or if both numbers are odd, if you do high minus low, so we did earlier, we did if both of them are odd, we return high minus low minus 1. Otherwise, if low now let's just say we had a different case. Let's just say low is even. Now the actual answer here would still be 3. But our new range would be 7 minus 2, which gives you 5. And there's still 3 odd numbers. If you did 7 minus 2, you get 5 numbers over 2. You get 2.5. So we floored it. Let's just say we take 2. So if low is even, then we have to add 1. If low even, add 1. Because then we could do 7 minus 2 equals 5 over 2 equals 2. If low even and odd and high odd, add 1 maybe. So we do 2 plus 1, you would get 3. Now what if they're both even? So we take all this and we say 2 going to 8. The answer is still 3. So if we do 8 minus 2, we would get 4 over 2, which would be 2, add 1. Okay. Now what if we take this one more step further and we just say, okay, 3 is odd, and low is odd and high is even. Do 8 minus 3, we get 5. Eight minus 3 is 5 over 2. It's 2.5. Floor it, we take 2, right? So if they're both odd, maybe you just 7 minus 3, 4 over 2, add 1. You get 7 minus 3, which would give you 4, over 2 would give you 2, you add 1, and you would get 3. It seems like you always just high over 2, add 1. So what if we just do high minus low dot floor, oh no, high minus low divided by 2 dot floor plus 1. Over 2, add 1, you get 3. Wait a second. 8 minus 2 does not give you 4. 8 minus 2 gives you 6 over 2, which would give you 3. So even same for this one. If you did 10 minus 8, 2 over 2 would be 1, and only one number is odd. Yeah, I think environment is going crazy again. It looks like this operation should equal this. This would be the default operation. And then if low mod 2, oh no, if they're both even, and high mod 2 equals 0, then we'll just return val. Otherwise, return val plus 1. I see. Yeah, it looks like yesterday we just had to sit down and think through it to solve it, but I think there's one of those times where you just kind of have to sit through and work the numbers. I was very opposed to that. So I would say this is constant time, basically, because we're just doing some math. Yeah, it looks like I'm gonna assume everyone pretty much ended up at the same solution. So we will take it. That was an interesting one though. And we did the last one in Ruby, so we'll try TypeScript this time. And this time we're gonna be doing Fibonacci number. So the Fibonacci number is commonly denoted. Fibonacci numbers commonly denoted f of n form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones starting from 0 and 1. So f of 0 equals 0, f of 1 equals 1, f of n equals f of n minus, and so on. It's 2 for n is greater than 1. So given n, calculate f of n. N is equal to 2 because 0 plus 1, wait, no. F of 0 equals 0 and f of 1 equals 1. Oh, okay. I was going to say the output is 1, but I was looking at n as the output. So the output is 1, 3. The output should be 2 here. 1, f of 1, f of 0 gives you 0, plus 1, plus f of 2. Oh, each number is the sum of the two preceding ones. I forgot. And so for f of 0 and f of 1, you f of 2, right, you'd be summing of 0 and 1, which would give you 1. Huh? Each number is the sum of the two preceding ones. So if we had 0, 1, 2, 3, the bindings aren't working. And I guess they're saying f of 0 equals 0, f of 1 equals the sum of the two. I guess f of 1, the base case that 0 equals 0 and 1 equals 1, right? And this would be the sum of 1 and 0 should give you 1, right? And the sum of the two preceding numbers would give you 2, and the sum of the two preceding numbers would give you 3. So I think there's a recursive way to string this all together, and I think there's probably an iterative way as well. So maybe, I wonder if there's a follow-up. There's no follow-up, so I guess we'll just do it the recursive way. So if n equals 0, we'll return 0. And my code editor has frozen again. Return 0, else if n equals 1, we'll return 1. Otherwise, we'll return the fib of n minus 1. Wow. Wait. So if we passed in input 3, it's not equal to 0, 1, so we do fib of n minus 1. Wait a second. I think I'm having some... I'm thinking of another problem instead of looking at this one directly. If we pass in 3, not 0 or 1, so we're going to take the fib of n minus 1. It's not 0 or 1, so we're going to take 2 minus 1, which is at 1. Now we're going to return 1, but we're not propagating the value at all. Wait, what is going on? Fib of n minus 1. I think we could definitely write an iterative solution, but for some reason I'm trying to focus on this problem. I'm thinking of another problem. We're not propagating the value. We're calling it with n equals 3. We're going top down, n equals 0, n equals 1, return equals 0, return equals 1. So then we're doing return fib of n minus 1. Wait, how are we stuck on this problem? Fib of n value is not propagating upwards. Fib of n minus 1. No, wait. The fib of n minus 1, then we'd go deeper. Oh, I think I see what the problem is. I think it should be the fib of n minus 1 plus the fib of n minus 2. So we end up with a lot of recalculating. Because it's the sum of the two previous numbers, and what we're returning is the fib of the current number. Well, not even the fib of the current number, we're just returning the Fibonacci of the previous number. So if we did this and we pass in through, we're going to say take the fib of n minus 1, which is 2. So we should get 1, and the n minus 2, we should get 1 again. Then we can sum them, because each problem is built up of the sub-problems below it. I think this should make more sense. I think we should run out of time here, though. Oh no, it says n only goes to 30. A lot of recalculating here, though. I think if we house this current time complexity, I think current time complexity to live with the two sub problems. Going all the way down, what would the time complexity of that be? If we start from 10, we have to do the Fibonacci of n and 8. So n numbers down. I want to say it would be, this would be linear. No, I don't think Fibonacci takes linear time. I'm pretty sure it's some, like, I think that's why it does, or maybe it's just as they're giving us a softball because n stops at 30. If you had to calculate the Fibonacci for a really large number, no memoization, you could still implement it. You could still use a set, we could use a map to memorize the calculations and then look them up so we don't reuse them. It'd be faster. But I can't tell how much faster it would be. Maybe. So this would be the real Fibonacci function, which would take n and a map, which would map a number to its Fibonacci value and return a number. And then we can just copy all of this into here. And the first one we'll actually do is check and I think we can actually remove this as well and say if map.has n, return map.get n. And the base cases we had earlier with 1 and 2 my environment has frozen again, but the base cases we had with 1 and 2 we can actually just inject into the map, I think. And then we can just call return f of n with the map. Oh, we're not actually saving it. Oops. And then we'll say let's say fib value, fib num is equal to that, and then we'll set map dot set n equal to fib num, and then you can just return fib num. If we're going top down, it just means that the next time we go down, I feel like it's faster for this one to go bottom up, but I wonder if there wouldn't be any difference. This one's even slower. This one is even slower. Wonder why that is. Yeah, this one's even slower. I guess maybe the portion where this would be faster would have to be on a larger number size. Hmm. Oh my god, now this is the problem. I'm not even passing in the map. So we end up recalculating it anyway. And also we're calling fib. We should be calling f. And somehow we still ended up with the correct answer. This is crazy. This is, I should just be thinking. I'm trying not to think and just... Right, so we have to stay out of autopilot. Creating a map, we set these two values, and we're calling the function f. We should have called it something that makes more sense so we could track its usage. Calling f with n with an empty map. Now, if the map has the values, then we want to get it. If the map, where the key is actually the Fibonacci number, or the fib is the number, and the key is actually the Fibonacci of that number, we'll return n, and then we will let fib num equal to f of n minus 1 with the map plus f of n minus 2 with the map. Okay, now this map looks like it makes a lot more sense. All right, move the console.log. Yeah, so okay, this makes sense. So it's marginally faster than the previous version, which is what I would expect. But in terms of the time complexity, I have no idea. I want to say this is... I want to say this is linear. I don't feel like the answer is linear. F of n equals f of n minus 1 plus f of n minus 2. Basically, oh, it's 2 to the n. Yeah, the linear time just didn't make sense. I should just, it is technically a tree problem, so we could have just drawn it out and counted the nodes. For each node it gets 2 to the n, so 2 to the 5th power. Application recurses too deeply. Improve upon the recursive approach using iteration. You otherwise iterate through n, storing each computed answer in an array along the way. Use the array as a reference to the previous two. Use this array as a reference to the two previous numbers to calculate the current Fibonacci number. So n is less than or equal to 1, return n. Otherwise they create a cache where 1 is equal to 1. Then we'll start at index equals 2, going up to n. Then cache is sub I, so let's just say index sub I is equal to cache sub I minus 1, should be 1, plus cache of I minus 2, which would be 0. Does this automatically default to 0 in Java? Find complexity O of n. Each number starting at 2 and at up to and including n is visited, computed, and then stored for O1 access later on. Size of the data structure is proportional to n. Oh, so you actually say we went for top down with memoization. Solve for all the sub-problems. Use memoization to store the pre-computed answers. Then return the answer for n. We will leverage recursion, but in a smarter way by not repeating the work to calculate existing values. Set the key n in our mapping. The value of n minus 1 plus of n minus 2, return the completed value. So yeah, they've created a map of 0 to 0, 1 to 1 that contains the key to return it. Then if you do cache.put for n, who have n minus 1 plus n minus 2, number starting at 2 up to and including n is visited, computed, and then stored for constant time access later on. Iterative bottom up. There's a constant space Fibonacci solution? That's crazy. Oh, they're right. You don't need to keep track of the array. You can just keep track of the last two numbers. Preset. You need three variables to store each state. Fib of n, fib of n minus 1, fib of n minus 2. Preset the initial values. Current 1, prev 1 with the zeros. Fib n minus 1. Computing the current value and prev 2. Since this will represent fib of n minus 2 when computing the current value. Iterate incrementally by 1, up to and including n. Starting at 2, since 0 and 1 are pre-computed, so the current value to prev 1 plus prev 2, the prev 2 value to prev 1 to the prev 1 value to current. When we reach n plus 1, we will exit the loop and return the previously set current value. That is clever. Yeah, you could just keep track of the last two values. That's really clever. Log n. Yeah, these is crazy solutions. Yeah, a lot of the constant time one I'm definitely going to remember. That is really cool. So transpose matrix, this has 410 dislikes. So we're given we're running out of time, we're just gonna read the problem. given a 2D integer array matrix, return the transpose of the matrix. Now when you flip the rows and the columns, the transpose of a matrix is the matrix flipped over its main diagonal, switching the matrix's row and column indices. So we have 2, 4, 1 going down. It's just I think a version of this could work if we started with a new matrix. So that wouldn't be doing really great on space. So we'll take up n by n space to store a temporary version, or an empty version of the matrix which we fill. I feel like you could just iterate across the rows of the matrix in the original and then just copy them going downwards in the opposite direction, where now instead of going by row, you'd just be going by column, so we'd swap the variables. So if we start with empty matrix, copy values over and swap R and column, would that work? So presumably we have a double for loop, should be m is equal to matrix length and n is equal to matrix sub I dot length. So m and n are different, but m and m are guaranteed. We're guaranteed a valid matrix where m is less than n, and m times n is less than 10 to the 5. So double for loop, we start at row equals 0, and our inner loop would be column equals 0, and we go boom, 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 come out of that, then we go row plus 1, and then we go like this. And then we could have another matrix which is empty with preset rows, the empty rows and columns, and then we'll just copy it over, right, where R is C and C is R. So we're on the left hand side, when we're incrementing column, we'll actually be incrementing row. We'll actually be implementing row. We'll actually be incrementing row, incrementing column. So this one we increment columns, we go boom, 2 to 4 to 1. So C1, C0, C1, C2, and here we'd be at row 0, row 1, row 2, which would restart. Now it'd be at row 2 here, but that would actually be, or row 1 here and column 1 here. So we have like 3 minutes left. We'll call T, which is going to be the transpose. It's going to be an array. The bindings don't work. And so here we just want to set up the array. So we'll do starting from 0, going up to matrix.length each do, we'll have R. And then we can duplicate this again in here. Here we're going to go from matrix of R dot length, and this is going to be C. Actually, we just need the number of rows, or the number of columns. I have to be careful here because I think we do want just the number of. So you transpose it. They're hiding some information here because when you transpose a matrix that's not symmetrical, the shape changes. So it's not that simple, but the rows become the columns. So if we had n rows, if we had 4 rows, 3 columns, we now have 4 columns. So since we'd have 4 columns, yeah, we ran out of time. We have 30 seconds remaining, so I'm gonna call it here. But this problem looks pretty fun.